Welcome to Chapter 11, Section 3, called Slopes of Lines. This is for Integrated Math 1 or IM1. So a couple things you'll notice on your screen. The first thing you should see is a due date. I don't see it on my teacher preview here, but you will see it on your student screen. The number of attempts is always unlimited, and that's true for homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is the one you keep. Partial credit is enabled, so if you answer 1 of 5 questions correctly, you get credit for the one question or however many you answer correctly. Please remember, once you start the homework, you must finish it before you can work on anything else. What that means is once I click start, there will be a submit assignment button down here in the bottom right corner. And this is how we finish an assignment. So when we're all done, or we want to leave the screen, not when we're all done with it, because sometimes we might not finish all the problems, we want to click submit assignment. You don't want to just close the tab or close your computer, because then Alex is going to assume you want to leave this attempt open, and it's going to lock all of your other assignments and resources. That's what it means by you can't work on anything else. So to avoid getting locked out, click submit assignment. It'll save your place. It knows where you are, and it'll start you back up where you left off. And the other thing that it will do when you click submit assignment is it affects the gradebook, so your teacher can see what you've been working on. Up until that point, your account's kind of frozen. So just make sure you always click that button. On the side here, we have explanation, example, and message center. So explanation tells us we're going to lose our current question attempt because it's going to give us the answer to this question. So it's not going to give us the answer and then let us come and type the answer in. But example will give us a very similar example to what it is we're looking at. It'll teach us how to solve this problem, what to do, and what to type in here, like how to type the answer in. You can close this, you can open another example, and then you can also message your teacher directly from this screen so that it'll attach a picture and we know where to come help you. All right, so one other note I'm going to make on this video is I'm reusing some of my older videos that I've already created, just kind of saving time there. So the numbers may not match up perfect, but they are in the correct order. All 5 questions are here. You just may notice that the question numbers are a little bit off, but in the correct order and all the same questions. All right, so let's go ahead and get started. Okay. So this one, when we want to find the slope of a line and then we're given the graph, you can do this visually on the graph. You can go from one point to the other, and we want to think of rise over run, because remember, that is always our basic way to remember slope. We have rise, which is our change in y's, over run, which is our change in our x's. So rise, if I want to go up to kind of the same level as this one here, I'm going to go 1, 2, 3. And now I'm on the same line as this guy here. So I went up 3. And then I'm going to go to the right 1, 2, 3, 4, 5 to land on that same point there. So it's positive 3. I went up 3, and it's positive 5 because I went right 3. So be careful about positives and negatives when you're doing this. Up is positive, down is negative. Right is positive, left is negative. So you just want to be careful about that. And you can type this in. You can either hit the little fraction bar or you can hit the backslash on your keyboard, and it will also put the fraction bar in there for you. Make sure these are reduced. So if you do have a fraction or a number, numerator and denominator that can both be reduced or divided by the same number, you want to make sure you do that first. 3 and 5 are both prime, so they are good to go. All right. So again, visually, pretty easy to do. We're just counting rise over run. If we have points, now we have to use the slope formula, which if you click on explanation, if you don't know these, they should give you this background really quick so that you know, oh, okay, here's my actual slope formula. So instead of just rise, because I don't visually see this, I can go y2 minus y1 over x2 minus x1. And what these y2 and x2 mean, and I'm going to go m equals because m is the letter we use for slope. But what y2 and y1, x2 and x1, what these 1s and 2s mean is it has to do with the points. So remember, we always have x and y like this. Well, now we have 2 of them, and we don't want to get confused on which one we're talking about. So we have x1 and y1, which just means it's from point 1. And x2 and y2, which means that they are from point 2. That is all it means. It's just a labeling system, so that we can very quickly say, okay, well, what's y2? It's going to be, the y coordinate for my second point. That's what that means. So we can plug these in, so that we can figure out what the slope is when we're given points. You can also graph it and then do some counting there, but you're actually doing the same thing either way. We're going to figure out the change in y, which would be the same idea as counting it, and then we're going to figure out the change in x. So with this one, if I write these down here, I have 2, 5, 8, and -4. So now I can see if I want y2, I can go y2 and go right underneath, it's going to be -4. Minus is part of the equation here, don't change that. And then y1 is going to be 5. Oh, why did it undo that? 5. And now I'm going to go to the bottom, my denominator, I have x2, so here's my x-coordinate for my second point, minus x1, which is 2 in this case. So now I just need to solve these. -4 minus 5, that's -9. 8 minus 2, that's 6. So this is an example that needs to be reduced. We want to type it in -9/6 because both of these can divide by 3. So we need to reduce it first. And Alex would have warned me about that if I try to type this in. And I can even show you the warning that it'll give in just a second. So -9 divided by 3 is -3. 6 divided by 3 is 2. So before I type in that correct answer, well, they're both correct. I don't want to say correct answer, the reduced answer. So 9/6. I'm just going to show you when I try to do this one, it's going to give me a warning and say your answer is correct. However, the fraction can be simplified. So it actually even gave me the point for it already. In some situations, it's going to say that's not reduced. Make sure you reduce it before it'll even give you a point for it. So it just kind of depends on where you are within the system here on how much it's expecting you and how far it's expecting you to go. It didn't say completely simplified, so that's probably why it's not marking us wrong on it. All right. So we are going to do this a couple more times here to show there's a way to identify that 0 and that undefined slopes when you're looking at the equation here. So remember, slope equals y2 minus y1. Losing my mind here while I'm talking. All right. And we have x1, comma, y1, and x2, comma, y2. Okay. So let's go ahead and look at this first one. We have -6 and 3. We have -6 and -7. So if we start plugging this in, we have -7 for my y2, and then we're going to say minus y1 over x2 minus -6, because it's x1 is -6, and this minus is a part of the equation. So we need to make sure they both go in there. It's minus negative. Well, that's a double negative. That's just the same thing as multiplying two negatives. So this actually becomes a plus whenever you hear a double negative like that, minus negative. So this is going to equal -10, -7 minus 3 is -10, over -6 plus 6. Well, those are opposites. I subtract and I get 0. We can't divide by 0. Remember, the bottom of a fraction, the denominator, tells us how many points there are available. Or not points, but how many pieces are available. I'll say it that way. Well, in this case, I have -10 of 0 pieces. Well, that doesn't make any sense. How do I have -10 if there weren't any pieces to begin with? So, once we have 0 on the bottom, we immediately say this is undefined. That is a vertical line going straight up and down. And that's exactly what it means. It means we're dividing by 0. That's why we say it's undefined. So now if we look at the second one here, I'm just going to stack these. So this, just so I don't have to rewrite everything. So we're kind of ignoring this one for a minute, just so that I can kind of reuse these. So now we have y2, that's -3, and y1 is also -3, so it's minus negative again. X2 is 8, and x1 is -2, so it's minus negative again, like that. So minus negative, that becomes a plus, minus negative, that becomes a plus. Well, -3 plus 3, those are opposites, so they become 0. 8 plus 2 is 10. This is a legitimate answer. This is not undefined. 0 divided by anything is just 0. This just means I had 10 pieces and now I have 0 of them left. You know, maybe you ordered a pizza and there were 10 pieces on that pizza and everybody ate them. They're gone. That's a legitimate problem. But in this one, this is saying that, you know, I started with 0 pieces. Maybe we can even talk about pizza. I started with 0 pieces of pizza and now I'm missing 10 of them. There's negative 10. Well, that doesn't make any sense. I started with 0. So how am I missing anything? So that's just the difference between 0 on the denominator and 0 in the numerator. So this is a 0 slope. So we just type in 0 here. Check. All right. Trucking right along here. Okay, so this one's a little bit different. So we still have our same equation here. X2 minus x1. And we still have our pieces here. X2 and Y2. But now it's saying the points 5, 9, and 7 R lie on the line with a slope -5. Find the missing coordinate R. So now we're given the slope. Remember, that's what M is. It's just the variable we use for slope. And we're missing one of the coordinates. But we still go through and we plug it in just the same. But now we're going to have it equaling a number already. So we have 7 and we have R like this. So I have M, remember that's my slope. So -5 equals Y2, which is R, minus Y1, which is 9. And then X2, which is 7, minus X1, which is 5. So now I'm going to reduce this bottom one by saying 7 minus 5 is 2. And when the entire side is being divided by a number, I want to multiply by that number so that I can kind of get rid of the fraction issue here. So 2 times -5 is -10. And then 2 divided by 2 on this side cancels out. So I just have R minus 9. So that's why we want to multiply by whatever that denominator is on both sides, because it eliminates the fraction on the side that it's on. And now all I have to do is say plus 9, because I want to eliminate these guys, and R equals -1. -10 plus 9 is -1. So R has to be -1 in order for -5 to be the correct slope. So that's what we need it to be. All right, a couple more of these guys and we will be all done. Let's go ahead and get started. So on this one, just like we were looking at on that example, we're given a slope and we're given a point. So remember, when we're looking at points, oops, I gotta change that to the chisel marker. So we're given this point here. This is where we're going to start, is at our point. If we were given y-intercept, that is where we would start. So it just depends on the pieces we're given. But if we're given the y-intercept, it means that we just go up or down to that number, right? It's on the y-axis. But if we're given a specific point, so from the center, from the origin here, we're going to go right 4 and up 1. Remember, this is just a direction system. So think of this as like I'm standing in the middle of a city, and I want to get to this point here. So I can't go through the pieces that I want to go. I can't go through, or not the pieces, sorry, the buildings. I have to walk along the street, right? So I'm going to walk along the street to 4. That's going right 4. And then I'm going to go up 1. And that's where my point is here. So I'm going to go ahead and put my point. So that's where I want to get. I was started here, and I walked, and I walked. So think of it like city blocks, if you can kind of picture that in your head. It's just a direction system. So from this point, we can use slope. So remember, slope, if my slope is 3, well, this is rise over run. That's how we remember slope. So this tells me how far up or down to go and how far right or left to go. Again, just more directions. So if I'm given an integer, we have to remember that there's a 1 under it. Anything divided by 1 is itself. It doesn't change it. So the 1 is there even if we don't see it. In fact, when we just have an integer, that's what the run will be, is 1. So with this one, I'm going to go up 3, and I'm going to go right 1 from the point we just graphed. So I'm going to go 1, 2, 3, and write 1. So again, it was just more directions. I wanted to get to a brand new point there. Now, I can go ahead and connect these two. And we are good to go. All right, let's keep moving here.